In this video we want to look into how we can reorient our stones, or in this case Voronoi cells, based on like guiding geometry or amateur geometry. Like you see here, based on this curve that I have drawn here in Rhino, I can change the curve, and based on that the orientation of these stones will, or Voronoi cells, will change. The second way how we can do that is by assigning a point. And just orient all of the Voronoi cells that we generated in the previous set based on a vector generated from the starting or the center points of these blocks here towards this point. So let's get into it. So first what you want to do is you want to turn off all your exports here, and we want to bring in a new orient, just to have a new part of the algorithm here. So we bring in this geometry, and then we could use the source that we have over here, or we could also start with this geometry. Now you see they get the geometry gets mapped over here because actually the target plane is the XY plane, which is this one here, but we want to define a new plane. And how can we do that? Actually, we want to define a plane based on the existing points here. So you can imagine, instead of this plane here, we have these points now. So you see, you can easily extract the points from the plane by plugging it in here. And now we have to find a way to change the orientation or define a new plane at these points here. And in order to do that, I would suggest that we use a point that you can place in Rhino over here. And we want to create a plane that is based on these points and has a normal direction like this. We need a plane over here, target plane, a new one, and we want to have it placed here with an orientation pointing to that. And you can imagine that a plane is defined by the XY axis. If we zoom in, you see it over here, the green axis, and the red axis, which is the red is the X and the green is the Y. You see that also when I select something, it has an X coordinate, the red one, and a Y coordinate, the green one, and then the Z coordinate, or the Z axis, which could be equivalent to the normal of an axis. So a little hint how to do that is you might want to go into vectors, because that's where, again, this exercise is for you to figure out how you can develop your own scripts. And one way in order to develop a plane is, obviously you have to search a little bit for it, because it's not very intuitive for most people in the beginning that the plane is to be found under vector over here, and then you go into plane, and then you see there are plenty of options how you can generate, or you can even deconstruct a plane. You can use this world XY plane. And what I want you to do now is to look at these ways how to construct a plane, and then just drop them over here on the canvas and get an understanding what which component does. So for instance, if I plug in the XY plane, you see it creates this XY plane in the 0 point of our file. While if I change the origin, which currently is set to 0, 0, 0, instead plug in this, you see now we have this XY oriented planes, but now at these origin points. which it doesn't really help us unless you want the stones to be aligned like this. Yeah, so now they are remapped from, and let me show you another tool here, preview, from this one to this one, yeah, from here to here. This allows you to, this preview selection here allows you to only preview what you have currently selected. Yeah, you see, it shows only what I select. You can easily turn that off again. And you see that this is not the right tool yet, so you have to find another one. And yeah, what I want you to do now is to pause and get a little bit your head around, try a little bit for yourself, which one makes most sense to use in this place. So pause, really try. I mean, actually, you could try all of them. I guess you will fall into problems. And keep in mind, you want to use this point, and you want to create kind of a normal over here. So there's a high likelihood that you also might have to use something else to create this vector from this point over here. Please pause now, think a little bit about it, try it out yourself, and then we'll be right back here with a way with one solution. You will see that there are a lot of different solutions. See you in a bit. Okay, I hope you had some success with your with setting it up. Let's try now together. So I would go to plane, and then you see there's, for instance, adjust plane, or there's plane, create a plane perpendicular to a vector. I would go for this. You might also use this one, but let's start with this one because this is so simple. It asks you for origin, which in our case will be this one, and then again you see it uses the z vector, which is just the 0, 0, 1 vector, and in this case the 0, 0, 1, because it's a vector, it does not define the location but the orientation. Yeah, so this is, has a 0 value at this axis, 0 value at this axis, and a 1 at this pointing upwards. So we have to change that. And how can we do that? We need to create a new vector basically, and we want the stones to be determined by this point here. So creating a vector, we go over here, we see again we have this basic vectors. So not really what we're looking for. We have amplitude, which changes the strength of a vector somehow if you want to keep it really simple. And what we want to do is we want to create a vector between 2 points. Yeah, we want to use this direction here. So we bring in this, and you see this one asks us for a point A and a point B. So let's plug in the starting point, which is this point, and then a point over here. So we have to create a new point by just double-clicking, point, right-click on it, set one point. Yeah, and it directly selects this point, bring it into B. You don't see anything yet because it doesn't visualize that. If you want to have a visualization of that, you can very easily go here into curve, and for instance, you could create a line segment defined by a starting point. So again, we have a starting point, and we have a direction, and we have a length. So now you have this line that is based on your vector, just for visualization in this case. And now we bring in this vector into the z-axis. And you see it changes automatically the orientation. And if we move that, wherever you move it, it will orient these new planes towards this point based on this vector that is defined, or that's visualized by that line. And now we just plug this in here. And you see that also your Voronoi cells change orientation based on this. So it's a simple task. Keep in mind that you can use that for any geometry, basically. So let's save that for a moment. Again, group this, so you have that a little bit organized. You have here your two inputs, and yeah, the source plane. Actually, yeah, you don't need that, but let's keep it for now like that. Now I want you to think of a second way how we could do that. Again, we want to orient our parts, but this time we don't want to use a single point, but instead we want to use a curve that helps us to orient. Yeah, we could have used that, drawn that in the front. Let's bring that curve a bit closer to our, actually bring that a little bit closer, move it over here, move that point down. So we have a curve, and now instead of using the single point here, I want you to think about a way how you could create a orientation where each of these planes has a different orientation towards a point on that curve. Yeah, so again, we know we use this geometry. We have our source plane. And now I want you to think of a different orientation. So yeah, you might reuse a little bit of what we had before, but now you have to figure out a way how you can find points on that curve. And again, click through. Just a little hint again, you might look here into curve and then division for something you can find. So yeah, again, take, I guess, 10-15 minutes, something like that, to get your head around how you could define a new definition that reorients that towards a point each plane. So you need 6 points on this curve to reorient it based on this curve. See you in a bit. Okay, everyone. So I hope, again, you had some success. If, yeah, you didn't find the right solution, or if you were interested in how I would have done that, it's really about testing a little bit and get familiar with the possibilities of Grasshopper. So we go over here, and I know that I want to divide this curve. And now you see it asks us for a curve, a count, kings, which are not so important. So we have to bring in the curve. We type curve here. This is, again, linking Grasshopper to Rhino. Set one curve, multiple curve, doesn't actually matter. Plug that in, and now you see we have 10 points over here. So instead of 10, we need 6 points. 1, 2, 3, 4, 5, 6, 7. Yeah, little mistake, because it divides the curve into segments. So we only need 5 segments. Yeah, 1, 2, 3, 4, 5, in order to get 6 points. So again, we have the points. And now we need to create a plane again from these points. Yeah, similar to what we did before. We want to draw vectors from here to here and then create a plane. So we can actually reuse a little bit of this. We would just go over here, press C, press V, bring it down here. Let's move that a little bit for clarity. And now it gets a little bit complicated. We have to change a few things. So the base points stay, but we have to exchange these points over here. So let's bring this in. And yeah, we have to bring in these. Let's visualize this. That might be a common mistake that you have visualized. You see that instead, probably you want to have this point associated with this point on that curve. Easy fix is just go and flip this curve. Yeah, go, select it, type flip, and it will automatically flip flip the direction of the curve, change the direction of the curve. So instead of starting from here, it's now starting from here or the other way around. And then we bring in this plane over here, and there you see, there you go. Now the orientation is based on this curve. And if we change the curve, this point obviously changes, and the orientation of my curve changes. And again, organize these files a little bit, move them over here, group them to guarantee readability of these things and make it easier for peers or whoever comes after you to read your files. So I hope you enjoyed that. Thank you very much for watching, and if you have any questions or if you find other solutions, because there are probably, I don't know how many, but there are definitely, I don't know, 2, 3, maybe even more other ways how you could achieve the same with just a few different commands in Grasshopper. And would be interesting for me to know which one you found. Thank you very much for watching, and see you soon.